This is Anant from Camphor Networks. Today I would like to introduce to you Camphor Multi-Cloud Gateway, a new state-of-the-art, purely software-based networking gateway appliance, if you will, that one can use in AWS and other cloud platforms in the near future. We intend to support multiple features using this common gateway such as NAT, transit, VPN, load balancer, firewalls, etc. In this video, I would like to focus on how the NAT functionality can be achieved using Camphor network gateways. Okay. So a little background why we are doing this, right? So if you look at AWS, they natively support a very highly scalable and optimized NAT gateway called NAT gateway. If you look at the pricing, you can see that it has a fixed cost of around 4.5 cents an hour, like a dollar a day, and then there is an additional fee of 4.5 cents for every gigabyte of data processed. Now, this is significant because this is a fee that is applicable for all data going through the gateway in any direction, whether it's going outbound or coming back inbound, irrespective, it is going to be charged. And this can go pretty high over time, especially when you transfer, gigabytes, terabytes, and petabytes of data continuously. But what is the advantage though? Of course, it's highly scalable. It gives you very good performance. It is always there and it is elastic and whatnot. So that's the beauty of this, right? What we want to provide is provide a similar functionality using Camphor Gateway, but our plan is not to charge on the gate at all. We'll just charge a premium on the compute resources being used, which the customer, you as a user yourself get to own. There will just premium just like if you use any other third-party AMI, but you still get all the functionality. So that's the idea. Okay. So let's go ahead. The way we start, we can use the launch it in AWS is using a simple cloud formation template. I have a URL copied to the clipboard. So this is the template, CloudFormation template, and we can go ahead and use it. In this demo, we're going to, let's say, create a new VPC. We can create a new VPC to install everything. We can use an existing VPC as well, which is probably more likely in a production scenario. Let's choose some other the zones where we want to install these gateways. I'll talk about it a little bit later once we start the process, and rest you can for now keep it as it is. Okay, this is the key part, load balancer. How do you actually get the scale? The way we get scale is by using load balancer, right? There are few choices we can use. There are three fundamentally: single scale auto scaling group, gateway AWS gateway load balancer based auto scaling groups, and then there is a Camphor load balancing based auto scaling. So today I'm going to use Camphor load balancing, which is already turned on by default, and so we don't need to worry about it, the rest of it. So let's pick around 2 instances in the auto scaling group for these NAT gates. So totally we'll have 6 Camphor gateway instances. Okay, and that's all. And there's a whole bunch of other things you can customize. We can talk about it in another video once you're interested in this. Right? And then in order to test it, let's have some test instances. So I can show you how the NAT functionality works seamlessly. Okay, and that's all right. You acknowledge, and we have to create some IAM profiles in order to create these resources, and for that you have to give an explicit permission. Okay, in case there's a failure, we if you want to look at logs, etc., it's good to keep the resources, but I expect it to work fine. So that's all. So once we are ready, so let's initiate the process. Okay, so that's all right. It's very simple. As you see, these are the bunch of parameters that we have configured. We have kept pretty much most of them default, except for a few of them. Okay, now it starts processing it. Now we're going to get some resources configured, and it usually takes around 5 minutes to complete, which is comparable to a NAT gateway startup from AWS, which also takes 5 to 10 minutes typically to complete. Okay, that's that. So let's make sure that we also get the logs. That will happen once the basic Lambda functions are created. So yeah, Lambda function is created. So we should see the logs here soon. Okay, there you go. So I just want to start tailing this. Okay, so that way we know what's going on. And now let's go back to the template. So here's a template. You don't have to worry about the details. There's a whole bunch of policies and resources that we create. I just want to emphasize that we have taken extraordinary care to make sure that we only take those permissions from the your user account using IAM policy that is required in order to give you the feature set that we are promising to. There's absolutely nothing else. Every single permission that's being taken is actually scoped to the name of this autoscaling, the Camphor gateway group, which itself has a random name inside it. These random string generated by AWS. So it's very secure, very containerized, if you will, from a logical perspective, and you can use it with 100% trusting Camphor networks. Okay, anyway, so let's go back, and I wanted to showcase a picture. Okay, so let's go to this template. There is a picture here. How does this whole thing work? Excuse me, sorry. Sorry about that. So there are three modes that you can use these gateways. Okay, and one is using AWS Gateway Load Balancer. What exactly is this? So, see, the way the routing works in AWS, in a given routing table, you can have a destination uh, next stop as only one. Meaning, for a given destination, for internet, it's let's say 0.0.0.0/0. You can have only one next stop. But typically, if you're running your own AWS instance, in order to do the NAT, then you can only have one instance. You can't scale horizontally. That's the problem. So in order to solve it, they have provided something called AWS Gateway Load Balancer, or rather Gateway Load Balancer. This uses Geneva protocol in order to be able to load balance across multiple recipients. So you can use that using this CloudFormation template. It's just a simple click, toggle Gateway Load Balancer to true, and you will get everything. Okay, even this you can set it in half form mode and all that to get further, but it's going to cost you 1 cent per gig of data process. Okay, that's the catch. Every data bytes, gigabytes of data passing through, 1 cent will be charged. Okay, that's one mode. Another mode is Camphor Load Balancer, which is you kind of run a simple daemon software in your client instances such as VMs and containers. Actually, you just need one per operating system, and that will take care of doing the load balancing directly. So that way you can completely avoid the gateway load balancer cost also, and you get full high availability as well as horizontal scalability. That's what I want to show you in this demo. In additional videos, I'll show you the other way. The last but last and least, not the least, there is a single instance mode also if you want to use with auto scaling group scale. I would call it up and down. No. So for example, you can use this a single instance in your auto scaling group and enable single instance mode. And let's say you pick T3.small as your starting image. Dynamically, as the demand goes up and down, we can scale up and down to a bigger instance or a smaller instance based on the demand. Okay, and this will happen in place, so you will not have any disruption also, and it also works seamlessly. So this also is a very useful way to do, but not just for NAT functionality, but even for any other functionality, especially stateful functionality. If you have, you can use Camphor Gateway Image Extended to get this cool feature of auto scale up and down. But anyway, in this video, I would like to focus on Camphor load balancer based auto scaling group. Okay, now we have three auto scaling groups that we'll configure in this topology, one per zone. Why do we do that? Auto scaling group inherently provides multiple zones, and that's the whole concept actually, that you can scale across the zones and hence you get high availability, which is great. The way we have done it is slightly different. We used all that techniques, but we do one per zone because we want to be able to scale independently. See, for example, if let's say you're a client and you're sending traffic to one of these gateways. Okay, if you happen to choose a gateway which is not in your zone, so let's say you're in zone A and you send traffic to zone B, there is going to be an inter-zone traffic processing fee, or rather transfer fee, that's going to be applicable, which is 1 cent for every gigabyte of data, and that's going to add up, right? So ideally you want to avoid that. So then you say, okay, I know I'm going to only use the instances of my local autoscaling group. So that's how we create these separate groups. But the problem with using a single auto-scaling group is that, let's say in zone B, there's a high traffic, okay? And then because of that, we have to expand. And let's say auto-scaling group, we expand and add one more instance. Then if the traffic is actually now going up in, let's say, zone A, then that's not useful, right? Because your zone B, you may have more instances, but your zone A is suffering, and you're not going to get any benefit if you are going through the zone A gateways. That's why we have divided into separate auto scaling groups. Each one will scale independently based on the network, CPU, and memory, I would say, the usage, which is all you can customize, by the way, heavily, and then you can get the full benefit of the auto scaling group. Okay. So this is how, and last but not least, we're going to also provide you DNS names, which is awesome. So basically, with Camphor Gateway, what we have is automatic. Everything is automatic. Okay, 100%. I'll show you right now. You're going to get your own domain name. In this case, it's a private domain name. We'll get one domain name for the whole gateways across all the zones, and then we are also going to get one domain per zone, availability zone as well. You can use those domain names in order to send your traffic. If you are using layer 7, for example, using a web proxy based software, so you can do that, right? So you get fully DNS based discovery and usage as well. Okay, let's take a look at what's happening in the logs. I don't see any. Okay, there it is. Okay, so it is refreshed and it did its work and it's actually completed. Success. Let's see how much time it took. So it took, like around, how much is it? Around 12 minutes, if you will. So really not much, like within under 15 minutes, it completed successfully. Okay. Actually, I'm sorry, this is only 70 seconds. So it's actually just a minute and a quarter. All right. Okay. So let's look at what we got here in the instances. So we got totally, how many? We got 9 instances. Out of these 9, 6 are production like NAT gateways, and 3 of them are for testing purposes. So we have 3 autoscaling groups: A client, B client, and C client, who will use which will use can for testing purposes. Okay, and these are the gateways themselves which will do it. Okay, let's look at the VPCs. We asked it to create a new VPC for this demo. There should be one. If you go to VPCs, so this is the one, Camphor NAT Gateway 1D. This is an automatic unique ID generated by the CloudFormation, which will attach it to all the resources. So if you go to this VPC, so you can look at this nice resource map. You can see that we have created a bunch of resources. Okay, we create a subnet, routing tables, and whatnot. You don't, as a user, don't have to worry about it. What you need to look at is that we create a route table for you for the clients, multiple route tables actually, but at least one which is useful is what is called a main table. Okay, so we will create one main table for each zone in this example, which any subnets in your use case you can connect it to this routing table and make use of it. What does this routing table contain? It will contain a default route pointing to one of the, I call it as a primary instance of the autoscaling group in the local zone. Okay, so even with, let's say, if you don't have any load balancing anything, you always have internet connectivity through this primary instance. Okay, but you won't get fully load balancing here using this table, but at least you will get an immediate access, especially the bootstrapping and all. So you will get that. Okay, and let's look at, I want to show you the outputs. After CloudFormation is successful, you will get a whole bunch of outputs. The basic information is here. By the way, you can also use it easily with Terraform and Python SDK and other form of programmable interfaces that you want to use in order to instantiate it. Okay, I have put all the additional information like access keys and etc. in a separate bucket, if you will, not bucket, like storage bucket, more in a AWS Secret Manager, where I have put all the useful information. So this is kind of go-to for the user, where you have all the information that you need, including private keys and passwords and whatnot. Okay, so let's look at some of the important ones. I talked about DN. I mean, these are, let's see what all we created actually. Right? Here I have given even URLs for all the resources created at the bottom. So like we create security group, auto scaling groups, launch templates, logs bucket, DNS names that I wanted to show you, and then there's a whole bunch of web proxy that also you can use, routing tables, subnets, and whatnot. Okay, so let's look at the DNS name, what's happening. Okay, so as I told you, there's one common one that we create for the entire set of auto scaling groups. Let's take a look at that. What I expect is, yeah, awesome. So we have, if you see, there's a record pointing to the name of this private name here, which is the name of the autoscaling group, with all the 6 instances here. Okay, A, B, and C. All of them are in this group. So you can use essentially this DNS domain name to access any of them. So you can load balance to all these guys. Okay, especially if you're talking from an application layer. For example, if you're doing a curl or if you're using web proxy and things like that. Okay, and then there's a zone specific also. So let's say this is, they have one for each zone here. Zone B. Let's look at zone B. If you go here, you will see that it will only have, yeah, it only has two instances in this domain registered already automatically, 46 and 41. These will be the one, those that are running in zone B. Okay, so let's check that just to be sure. 46 and 41, right? So if you look at the instances, so this is one which is 41 and the other one should be 46. Awesome. Okay, so now we have all the DNS names also set up. So then let's go to the client and see if the NAT function is working in the first place. Okay, as you can see, the NAT, we have created a few autoscaling to test purpose. This one doesn't have any public IP address, it only has a private IP address. Okay, you can access the one of these gateways which will have a public IP address like this, and from there you can go to private the client. Other option is to go from the console. So in this example, I'm going to go from the console directly. Okay, so let's close the route tables here, and I want to go back to secrets. So at the beginning of the secret one, we have the passwords also cached here. So let's click on the password, copy it. Okay, so let's log in. This client instance is is just an Ubuntu instance. Okay, let's log in. Okay, I want to be root. All right, so let's just make sure it's working. Awesome. Okay, so now what I have is that now this client gateway already has a client software installed in order to do load balancing. Okay, so I just want to show that quickly. Just a simple daemon, systemctl status Camphor gateway client. You can also run it as a container if you want to, but this software's job is to make sure that it will set up a like a multipath towards all the NAT gateway, so you get full functionality, full performance as well as high availability. Okay, so now let's find out whether we have internet connection. Let's just do google.com. Okay, and see if it works. Okay, we are ready to go. It's working, right? So now let's see how it's NAT is happening. What I want to do is I will show you the way I test is normally like this. So we'll access this web server, I believe, is ifconfig.me. Okay, what does this do is this website basically tells what is the public IP address that's sort of visible to it when we make a connection outbound. Okay, so now if I want to do it, let me see. Sorry, Carl, I missed a dollar. Yeah. Okay. Yeah. So this is my public IP address that this website outbound is able to see as mine. This will be one of the instances in my local zone. Okay. If I keep retrying, I should get a different one also because we're going to load balance. Let's see. Yeah, there you go. Right. So this is the other one. So we have two in each zone. In this, by default, we only use the local zone. So you're getting both as a round robin fashion, right? So this is actually based on the source port right now. So it varies and you get a load balancing. So this should be the gateways in your local zone. So let me check that. Okay, one is 44, one is 35, right? So if you go back here, one of them will be 35 as you can see here, another one will be 44. 4420, right? Perfect. So it's working like this. Let's say for the sake of argument that you want full scaling to across all the zones, you're okay to pay that additional cost of 1 cent for the inter-zone traffic. Then it's very simple. You just update the configuration of this daemon that we have installed. So I have a list here called availability zones, which is empty right now, meaning use always your local one. By the way, empty is also very smart because if you keep it empty, not only that we use the local zone, if there's none available for the sake of, let's say you don't have anything set up in your zone or they're down for whatever reason, then we'll use the gateways from the other zones. But if you have anything from a local zone, then we'll only prefer that. That is what empty means. But let's say we want to use all of them. Okay, so let's just do all. Okay, now if you give it some time, around 10 seconds, what will happen is that we'll start using all the 6 gateways. Let's just check with it. It's almost coming up. Okay, there you go. I think I have it now. So let's do it again. Now what we'll do, the way we'll test it is that now again we'll run the same command. Now we actually expect 6 different public IP addresses over time. Okay, so and the way to easily test it is I'm going to redirect to a file. Okay, and then I'm going to sort it to be unique. And to see what is the IP address I'm getting. Okay, so basically I'm just taking the output of this command, which will tell me what IP address, public IP address that I am connected outbound, and it's going to sort unique. And so now gradually we should get 6 of them as we keep trying. Okay, sometimes I've seen the rate limiting being done by the remote side. I've seen that it takes a little bit time, but or probably the rate limiting run from the AWS side, but that's because I'm using micro instances. Okay, you can see I got 1, 2, 3, 5. there should be six. Okay, right? So you can actually see now if I have six different public IP addresses coming from my curl actually. So basically now we're able to load balance to all of them. Okay, so if I see routing table, here there's a default route installed with six next stops. These six next stops are all six, all the six of them here. A2 in A, 2 in B, 2 in C. Okay. So this is really cool, isn't it, guys? I mean, now what you get is that you get the full capability of all the six gateways that can do your NAT forwarding, but there's no data processing fee fundamentally, and it's fully available, elastically scalable, and whatnot. Okay, so that's the beauty. Let me take a little bit of time to show how everything is set up. So if you go back, if you look at the auto scaling group, for example, if there are multiple groups set up, you can ignore the client ones because they're just for testing purpose. But for the production purpose, there's three, one in each in A, B, and C. If you click on, let's say, B, you will see that it has already integrations with all the instances, and you will see that instances are in service, everything is perfect, right? You can even look at the cloud watch, uh, because we've already set up all the necessary alarms that's required if you want to horizontally scale this beautiful NAT gateway. Okay, so let's say if you want to go to, let's say, all alarms, and you can see that if there's any alarm is set up here, it will actually show like this. But let's pick on one of them, which is higher one. We'll click, okay, this one for example. So this auto scaling group already has that saying that if you get any packet drops, okay, from an interface saying that Amazon, let's say, says this instance is taking too much package, they're not going to allow more, then there's going to be counter that's increased and advertised already, and it's there, and the advertised count is here, it is still zero right now. But if it does, if this line goes above this red line, and if you have the auto scaling group count max is more than the current number, then automatically a new instance will get created by the auto scaling group. Okay, and then everything is automatic, so you will get all the new instances will come up, it will register with the DNS, it will be ready to forward, and your clients will dynamically discover, and it will set up any CPP and everything. From a user perspective, you can use it just like cloud, Amazon's cloud, the NAT gateway, but you will get your complete high availability and scalability. I hope you liked it. I mean, this is extremely, actually, frankly, difficult to do. We put a lot of effort in order to make it fully usable. We support, as I said, not only CloudFormation but also Terraform, Python SDK based, and other ways of configuring and deploying this gateway. We plan to release it in Amazon Marketplace also very soon, hopefully in a month or so. Stay tuned. If you have any feedback, please let me know. And last but not least, I want to tell you that in the same architecture, we are going to further improve not just providing NAT gateway, but we are going to add firewalls, deep packet inspection, transit gateways, that is from inbound to outbound, from inside cloud to outside cloud. And on the other direction, from outside cloud to inside cloud, we will support, let's say, VPNs, we will support load balancers, we will support probably outpost gateways. All of them, again, we will not intend to plan charging on any data at all. The only thing we will be charged is a premium on the instances themselves, and that's about it. So anyway, I hope you like it. Please let me know what you think about this, the idea as well as the presentation. I look forward to hearing your comments and work with you if I can. Thank you so much. Appreciate it. Bye bye. And one more thing, my contact information. You can always go to my website, camphornetworks.com, and you can get additional information. You can also you can click on the demo, I think, demo link, and you should throw up an email also, and you can also email me using this link, which is info@camphornetworks.com. Okay, thank you very much, guys. Appreciate it. Bye bye.